Following on from the previous video, the second fundamental theorem of calculus allows us to have a new way of expressing a function. So when given this here, this is another way of expressing a graph, if you like. Okay, so but the thing is, when given this here, just this alone, we can extract a lot of information to build up what the graph will look like. So when given this, when given this, we can use, when just given this, we can extract a lot of information from this. So from this, from this alone, we can use a second fundamental theorem of calculus to get from here to here. Okay, so now we know what the derivative will look like. In some of the earlier videos, I told you that just accept that this graph looks like this. But now let's pretend you didn't know this. Okay, let's pretend we didn't know this. So when given this, just this alone, we can immediately extract this by using the second fundamental theorem of calculus. And then if you so now we know what the gradient graph will look like. So this graph here is what we're trying to obtain. We now know the derivative here. If you differentiate it again, it will give you f double prime. Well, f double prime, from f double prime, you can tell if it's going to concave down or if it's going to concave up. So from this alone, we can extract this and we can extract this. And there's something else that we can extract. We can extract f of 0 as well. So remember, this here will give us this graph which we're trying to figure out. But f of 0, so this is f of x here. F of 0 is actually 0. It's actually 0. Just from this alone, you can tell that f of 0 equals 0. Because because just looking at this alone, okay, f of 0. What is f of 0? F of 0 is really you putting this into here. Okay, so f of 0 is you finding the integral from 0 to, well, you're putting this x into this x here. Okay, so it's you finding the integral of 0 from 0 to 0. Well, the integral of 0 from 0 to 0 will always, whenever these two are the same, even if it's from a to a, the integral will be 0. So this alone here, you can tell that f of 0 equals 0. So what that means is that the graph that we're trying to figure out here, f of 0 will be 0. So we know that the graph will cross over at the origin. And then now looking at this, here, let's try and figure out f prime of 0. Well, when you put this into here, f prime of 0 is really, then this whole thing here will be e to the power of 0. E to the power of 0 is 1. So we now know that the gradient of this function here, the gradient of this function must be 1, must have a gradient of 1 at the origin. Okay, so we know that the tangent there will have a gradient of 1. Okay, and then looking at this here, well, I will continue in the next video. There's a lot more information we can extract. We can tell if it concaves up, if it concaves down, and then by looking at this, I will explain more on it in the next video.